lesson video for chapter 19, section 19.1. And if you want all my videos in one spot, then just subscribe to my channel. So we're going to focus on optics in this chapter. And so we're going to start with mirrors, and then the second section will be on lenses. So optics is the study of how mirrors and lenses form images. A ray diagram shows how rays change direction when they strike mirrors and pass through lenses. The incoming ray is called the incident ray, and it approaches the mirror. And the angle of incidence is the angle the incident ray makes with a line drawn perpendicular to the surface of the mirror. The angle of reflection is the angle the reflected ray makes with the perpendicular line. The law of reflection states that the angle of reflection is equal to the angle of incidence. So these are really wordy definitions. I have a picture on the next slide that shows you very easily what it's talking about with this perpendicular line. So what it's saying is that this is our surface. Here our ray comes in, it reflects and bounces off this way. This is the perpendicular line they're talking about. This isn't really there. This is just a perpendicular line. And so the angle of incident, the incident ray's angle with that line, should equal the angle of reflection. All right, that's all that the previous slide was saying in a lot of words. So a mirror is a flat, shiny surface. If it's a flat, shiny surface, it's called a plane mirror. When you look into a plane mirror, you see your reversed reflection, a right-left reversed image of yourself. An image is a copy of an object formed by rays of light. So we've all experienced looking into a plane mirror before. You probably have many of them in your home. So it reverses your left and right, but it's the same size as you. It's upright, just like you are. Like you're not going to look in a plane mirror and all of a sudden your image is upside down. To produce your image in the mirror, rays of light strike you and reflect. These reflected rays then strike the mirror and are reflected into your eyes. So the light hits us, the light hits the mirror, the light hits our eyes. Your image appears the same distance behind the mirror as you are in front of the mirror, and your image is right side up. It's like when you're in a mirror, if you want your image to get bigger, you get closer to the mirror, because then your image appears to get closer on the other side. If you want to see more of yourself in a mirror, you back up, because then your image backs up also. Alright, so the closer you are to the mirror, the closer your image would be. The further away you are, the further your image would be. But it is going to be right side up, as we discussed. A plane mirror always produces a virtual image. Although you can see a virtual image, this type of image cannot be projected onto any surface. A virtual image is a copy of an object formed at the location from which the light rays appear to come. So there's no actual image behind the mirror. It's just our eyes make us think that it's coming from behind the mirror, because that's where the light rays appear to come. So I can't use the mirror to project the image on a surface. When the inside of a surface of a curved mirror is the reflecting surface, then the mirror is a concave mirror. So I always like to think it looks like a cave, like you're going into a cave, so that's concave. The curvature of the reflecting surface causes the rays of light to come together. So you can see this picture. They come in, and then they come together and meet at a particular point. And here's an example. They have little lasers pointing, and you can see they all come together right here at this point. The point at which the light rays meet is called the focal point. So when the light hits a concave mirror, it comes together at what we call the focal point. A real image is a copy of an object formed at the point where light rays actually meet. So if you look on the previous slide, the rays of light are actually meeting right here. Okay, it's not like they appear to be right there. We can see it's not even behind the mirror. It's in front of the mirror, so that's where they're actually meeting. Unlike a virtual image, a real image can be viewed on a surface such as a screen. So you could hold like a piece of paper or something like that in front of the mirror, and you can actually see that image at the focal point. Of course, you'll have to kind of move the paper back and forth till you reach the focal point, so you can see a clear image. Concave mirrors can form either real or virtual images. It depends on where you are in relation to the focal point. Oh, and like this picture right here, it shows this girl and boy are looking at this huge concave mirror. And if you look, the girl is right side up, but the boy's image is upside down. Okay, and that's because look at the difference in the distance they are from it. So that means the focal point is somewhere in between the two of them. So when the object is farther from the mirror than the focal point, so F is our focal point. So So O is our object, I is our image. Okay, so the object is further away than the focal point. The reflected rays meet in front of the mirror, making a real image. So see, here's my image. So if I held up some paper or something like that, I could project it onto the paper. Okay, and notice that in this case, the image is upside down. And here's an actual example. It's a candle. Here's our concave mirror. The image is upside down. That means that the candle is further from the mirror than the focal point. However, what if you get close to the mirror? Well, when the object is closer to the mirror than the focal point, the reflected rays spread out and appear to come from behind the mirror, making a virtual image. So here's the focal point. We've moved the object closer. So now our image is on the other side of the mirror, which remember, that's where it seems like the light's coming from. The light actually can't go to the other side of the mirror. It can't pass through. So now we have a virtual image, so we cannot project that anymore. And so if you look, here's the candle, they've moved it closer, and so now we have that virtual image on the other side. So that was concave mirrors. Let's talk about convex. So when the outside surface of a curved mirror is the reflecting surface, it is called a convex mirror. So if this is your reflective side, it's called concave. If this is your reflective side, it's called convex. The curvature of a convex mirror causes the reflected rays to spread out. So whereas concave would kind of bend the rays together to make that focal point, when it hits a convex mirror, they just all spread out. So how do we get an image if they never come together? Well, that's where they appear to come from. So see these dotted lines? They appear that they came from this point right here and spread out. So of course, if that's where they appear to come from, this is going to be a virtual image. Convex mirrors always cause light rays to spread out and can only form virtual images. The image formed by a convex mirror is always upright and smaller than the object. So here's the candle with a convex mirror. You can see it's an upright image, but it's smaller. And then here's our object, and it appears that it's behind the mirror. Of course, it can't actually be. So it's virtual, and it is smaller than the actual object. So, section assessment. How is the angle of incidence of light related to the angle of reflection? Well, they are equal or the same. They are equal or the same. What type of image does a plane mirror form? Well, remember, the plane mirror, your image seems like it's on the other side of the mirror where the light rays appear to come from, so that would be a virtual image. A virtual image. What types of image can be produced by a concave mirror or a convex mirror? Well, concave, because of that focal point, it can produce virtual or real. Okay, so concave has that focal point. So remember, based on where you are in relation to the focal point, you can form virtual or real. Whereas convex, since it spreads the light out, it can only form virtual. Okay, so concave can form both. Mirrors can form both, virtual and real. Convex can only form virtual. And then how are real images different from virtual images? Well, real images can be projected onto a screen or a surface. Virtual images cannot be projected. Or you could say real images are where the light rays come together. Virtual images are where the light rays appear to come together. So it says, if you place an object 10 centimeters from a particular concave mirror, a virtual image forms behind the mirror. What can you infer about the focal point of the mirror? Well, remember, if you have mirror, focal point, and then your object, you're going to form a real image in front of the mirror. But if you go in between the focal point and the mirror, that's when you form your virtual image behind the mirror. So what can we infer about the focal point? We can infer the object is closer to the mirror than the focal point is. Or the object is in between the focal point and the mirror. And then last one, if you look inside the bowl of a shiny metal spoon, so we're looking like this, your image is upside down. If you look at the outside of the spoon bowl, your image is right side up. Explain. Well, what's the difference in this and this? Well, we have concave and we have convex. Okay, so you're looking in two different types of mirrors when you flip the spoon around. Okay, so you can just say one side of the spoon is concave, one side of the spoon is convex. Alright, so hopefully that gives you a little bit more understanding of plane mirrors, plane mirrors, concave and convex mirrors, and then the difference in virtual and real images.